This is section 3.3. We're going to be talking about asymptote, domain, and range for log functions. So here we have a graph of one of our log functions, and if you remember, for our exponential functions we had a horizontal asymptote that went left to right, and if you remember, log functions are the inverse functions of our exponential functions. So where we had a horizontal asymptote for our exponential functions, we're now going to have a vertical asymptote. And we always are going to denote asymptotes with a little dashed line, so you can clearly see that this blue line right here, this blue dashed line, is representing the asymptote of the function in this graph. You can also see that as I move along the function, the graph of my function gets closer and closer and closer and closer to this asymptote denoted here. But if we zoom in, we'll see that it never actually touches the asymptote. If I'm given a graph and I want to find out what the asymptote is, well, I can do two things that will help me determine it and be sure of my answer. So one thing that I can do is I can mark some points on my graph, some easy to see points. So right here we have 5, 0.5, 3, 0, and 2.1, comma, -1. And I know that the first value listed in my ordered pair is the x value. And so if I notice, my x value seems to be getting closer and closer to 2, and I can also use Desmos right now to show that that is also the case. So you can see that my x value is getting closer and closer to 2, and it will continue to get closer and closer to 2, but not quite reach 2. And if I notice my asymptote for the function that is graphed, this dashed line, all of my x values are 2. So the asymptote of this function must be x equals 2. And so the reason for this is because this x value of 2, so when x is equal to 2, that means I have every point on the coordinate plane where I have an x value of 2 with my coordinates. And so this means because I have an asymptote at x equals 2, this line, this vertical line, I will never have a point on my function that is 2 comma a number. I'm asked to find the domain of my log function. So domain is always all of the x values that your function can possibly have. So let's look at all the x values my function can have. So as I go to the right, I know that this function is going to go on and on forever to the right. So what does that mean for our domain? Well, it means we're going to go to the right towards positive infinity. So we went to the right, now we need to go to the left to find out what x values to the left my function can have. And as I go to the left, I run into the asymptote. And I know that my function will never include the asymptote in its domain. So that means that my domain will be from 2, not including 2, and that's why we have this parentheses, to infinity. Now let's look at what is the range of this function. Well, I know that range is going to be looking at the values of my function up to down, so that's all of the possible y values that my function can have. And as I go along my function, I see that my y values are steadily increasing. And I know that my function keeps going this way onward and onward to infinity, so my y values must continue increasing upward towards positive infinity. What happens as I go downward along my function? Well, I notice that my function continues to go downward on and on and on forever because it never is able to touch this asymptote. So that means that my range goes from negative infinity to positive infinity. So let's look at this function. So this is the function notation of this graphed function. It's just the common log, and you'll see what affects our asymptote is actually this horizontal shift that we found. So when we set the argument equal to 0, we get x equals a positive 2, which made our function shift to the right 2, and it also gave us what the asymptote was, which was x equals 2. Note, I have a positive 1 in front of my log function here right now. But, so if I have any positive number, this is going to be the shape of my log function. So, as you can see, it still starts from down here and goes up. However, if I have a negative number in front of my log function, like -1, for example, this is just -1, my function is now flipped. So it looks like it's starting up here and it goes down this way. However, nothing has really changed. My asymptote is still x equals 2. My domain is still the same. It starts at 2 and goes to positive infinity. And the range is also the same. So it starts down here from negative infinity and it goes upwards towards positive infinity. We're asked to find domain, range, and asymptote of log functions. We won't always be given a graph. Sometimes we'll be given a function. So let's talk about how to deal with that. So if we want to find the asymptote, we want to set the argument of the log equal to 0 and solve for x. To find the domain, we have to find all of the x values that keep the argument positive. Because remember, we cannot have negative arguments or arguments that equal 0 for our log. And for the range of log functions, it's very easy. It's always going to be negative infinity to positive infinity. Let's look at this example. I'm asked to find the asymptote, domain, and range. So first I want to find the asymptote. So I'm going to set the argument equal to 0. So when I set x plus 2 equal to 0, I'm going to subtract 2 from both sides. And when I do that and I solve for x, I get x equals -2. And that is going to give us the asymptote for the log function. In order to find the domain of this function, set up an inequality where the argument, so the argument is x plus 2, is greater than 0. For my argument to be positive, my argument cannot equal 0, and it cannot be a negative number. So the argument must be greater than 0. So when I solve this inequality, I subtract 2 from both sides, and I get x must be greater than -2. So my domain must be from -2 to positive infinity. And it's not going to be from negative infinity to -2 because, well, if my argument is -2, I get an argument of 0. And if my x value is anything less than -2, like -3, for example, -3 plus 2 would give me -1, and that would give me a negative argument. So that won't work. The range is very simple. It's just going to be from negative infinity to positive infinity. And I know that this is the case because this is true for all log functions. Let's work one more final example. In this example, I want to find my asymptote, and so I set this equal to 0. Well, the only thing that's going to make this argument equal 0 is if x equals 5. So x equals 5 is going to be my asymptote. Let's look at the domain. So I'm going to set the argument up as an inequality that is greater than 0. And when I solve this, I'm just going to add 5 to both sides. And I will get x is greater than +5. And so this means the x values of my function must be any x value greater than 5 and not equal to 5. So that means my domain starts at 5 and goes to positive infinity. And my range is from negative infinity to positive infinity.